this video, I'm going to be reviewing the projectile motion concept that goes hand in hand with your reading regarding two-dimensional motion. So in this video, an object's going to be traveling on both axes. It's going to be traveling up and down as well as side to side. So it's traveling on the vertical axis, which we're going to refer to as the y axis, and then it's also going to be traveling on the horizontal axis. And any motion on the horizontal axis, we're just going to label it with subscripts that have x's on them. So we have an object, and it's a ball, and let's say a cannonball or a soccer ball, and it's being kicked with an initial velocity. And we don't know what that initial velocity is. So that initial velocity, in an APC physics class, I label that initial velocity as V0. In honors physics and college prep, I would label it as VI. Either case, it has initial velocity. Somebody has kicked this soccer ball and with an initial velocity of V0. Now there could be a number in there, 20 meters per second, 30 meters per second. But for now, just to keep things simple, we're just going to leave a letter in there. And I'm also going to tell you that it's going to be kicked at an angle of 30 degrees, or it could be kicked at an angle of 45 degrees or 20 degrees. So instead of putting a number, let's just leave theta in there. Later on, we can always put in the numbers. So the first thing you want to do whenever you're trying to discuss and analyze projectile motion when an object's traveling in two dimensions, you want to make sure you understand how fast is the object traveling on the horizontal axis and how fast is it traveling on the vertical axis. So this object is traveling towards the right, and it's also traveling up. That's how it travels at an angle. So if it's traveling diagonally, then that means it's traveling to the right and it's traveling up all at the same time. Now it's traveling to the right, and we're going to label that as its initial velocity in the x direction. And it's traveling up, we're going to label that as its initial velocity in the y direction. Now how do you find the initial velocity in the x direction or the initial velocity in the y direction? You're just going to use your trig function. So if somebody says, what's the initial velocity in the x direction? You can simply say, well, it's cosine theta is v0x over v0, and then v0 times cosine theta gives you your v0x. You can do the same thing for your v0y. Sine theta is equals to v0y over v0. So v0 times sine theta gives you your v0y. v0y, remember, just means the initial velocity in the y direction. Now, the one thing to remember is if you're neglecting air resistance, as this object goes up and then comes back down, as this object goes up and comes back down, at all points, its x velocity is going to remain the same because we're neglecting air resistance. So its velocity in the x direction is going to stay the same. Unless there's air resistance slowing the ball down, its velocity in the x direction should remain constant. Now when we did this in Logger Pro, you noticed that it does remain constant. The velocity in the x direction does not change. So what I'm doing is I'm labeling the vectors that represent the x velocity in the x direction. This one has been drawn here, here, and here, and I'm trying to draw them all the same size. They may be off by a little bit, but they're supposed to be the same size to show that they're not increasing or decreasing in size. However, the one that will increase or decrease is this guy. This guy will decrease as the ball goes up because at all times there is an acceleration of gravity that we're fighting against. When the ball goes up, this y velocity is going to keep decreasing till the y velocity becomes 0 at the highest point. Then the ball starts falling down. Now, one of the questions we always ask is that acceleration of gravity, was that impacting the ball at all times? And the answer to that question is yes. At all points, when the ball is traveling in the air, acceleration of gravity is impacting the ball. Now, at some points, it may not be changing the ball's velocity because the velocity may be 0, for example, at the highest point. But even then, acceleration of gravity is impacting you because at that point, it's changing the direction of the ball. Because now the ball is going to start moving downwards. So you can draw the y velocity here to show a right triangle, or you can draw it here. It doesn't make a difference. You can draw the x velocity here and the y velocity here, and this is the resultant velocity. This is the velocity with which the ball was actually kicked because it has an x and a y velocity. So you can draw it here, or you can draw it here. Some people choose to draw it here because then they can see a right triangle easily, and then the sine and cosine it's easy to remember. Some people draw it over here. It doesn't make a difference where you choose to draw it. If you choose to draw it here and you want to stick to that for the entire problem, then you're going to have to draw it over here. And you're going to have to show that this y velocity is smaller than this one because of the deceleration of gravity, because gravity is slowing you down. And at this point, you won't even draw a y velocity because the y velocity is 0 at this point. So y velocity is 0, so I'm not even going to draw it at this point. And then when the ball starts falling back down, mirror images, so if this is a mirror image of this point, then this y velocity is going to be identical in magnitude. So its number numerically is going to be the same as this one, except its direction is going to be opposite. So its magnitude is going to be the same as this, because it's the same point, a mirror image of this point over here, and whatever gravity took away from me is going to give it back to me exactly the same way if they're symmetrical points. So the direction's different, that's why you're going to have to label this one negative. If you're labeling everything upwards positive, then this one will have to be labeled negative. Just like our gravity, if it's downwards, and if we're choosing to say everything downwards is negative, then the gravitational acceleration will have to be labeled negative. And then finally, when you get to this point, this velocity over here is going to be identical to this one over here, except in opposite direction, so it's going to be a negative over there. So the ball is going to travel, and it's going to hit the ground. Now this is important information to know, because it's going to help you figure out how high does the ball go, or how far does the ball go. So for example, if they ask you a question, when you kick this ball with an initial velocity of v0 at an angle of theta, and they give you numbers for v0 and theta, say how high does the ball go? So when they ask you a question like that, they are saying, what is this height? They're saying, how high, what is the displacement of the ball? They're asking you to find the y. Well, the y component can be solved. The trick is to remember that if you're looking at the y component, then just use the y variables. Say to yourself that when the ball was at this point, it had an initial velocity of v0. So I started off with an initial velocity of v0, and I ended up with a final velocity of 0. So this was my initial velocity. My final velocity was 0. So I had my v0. I have my v0y, and I have my final velocity, which over here will be 0. Because if you're trying to find how high it went, at the highest point, the final velocity is 0. So I'm focusing only on the y velocities. The initial y velocity was v0y, or whatever number you can determine using your trig functions. If you know your initial velocity is v0y, and you know as you go higher and higher and higher, the y velocity gets weaker and weaker and weaker until at the highest point the y velocity is 0, then you've got your initial velocity and you've got your final velocity. And you've also got your acceleration, and in this case your acceleration is negative 9.8 meters per second squared, or negative 10 meters per second squared. So now the question becomes very simple, because if they're saying find me the displacement, the y component, you look at yourself and you say, I got my three variables. I know my initial velocity y, I know my final velocity y, I know my acceleration in the y direction, which is negative g, and I can solve for my displacement using you're going to use your kinematics equations. Final velocity squared is equals to initial velocity squared plus 2ay. Now you notice I'm putting a subscript, a y subscript in there. That's only because some problems in projectile motion, in this particular problem, you're going to be doing two types where the ball is going to be going up and down and side to side. So when it's side to side, you're going to put down an x for a subscript, just like you see the x's and the y subscripts throughout this problem. So in the equation, the original equation in class that I gave you, you didn't have the subscripts of y. You just had v squared is equals to v0 squared plus 2ay. In this, I'm putting the subscript v subscript y squared plus v0 y squared plus 2ay. Just to remind myself, this is the y initial velocity, this is the y final velocity. So now I have the initial y velocity, I have the final y velocity, I have the a. I rearrange this equation and I can solve for my displacement. So that's how you're going to find how high the ball goes. Now, the second question they may ask you is, how much time does it take the ball to go from here all the way to here? Well, that's also a problem that's very doable, because if they ask you that question, you would say, well, Mr. Parvaiz, I know my initial y velocity is given. I know my final y velocity is given. And I can figure out what my acceleration is, negative g, so I can solve for my t using my equations for acceleration. My acceleration equation says final velocity minus initial velocity divided by time. And when you rearrange this, final velocity in the y direction minus initial velocity in the y direction divided by time, when you rearrange it for time, it looks like that. You've got your final velocity, which is negative, so you're going to have to put a negative value in here. And it's exactly the same as this value, except it's negative. Put that in here. Your initial y velocity is this value that you've already determined using sine. And your acceleration, you're going to put down negative 9.8 or negative 10. Do the math, and you've got your time for the entire trip. That's how you can find the time for the entire trip. They may ask you, what's the time for half of the trip? How much time does it take to get to the highest point? Well, if you found the time for the entire trip, just divide that time by 2, and you'll find the time to get to the highest point. Finally, they may ask you, how far does the ball go in the x direction? So initially they asked you, how high does it go? But now let's say they ask you, how far does it go? They want to know this distance. Let's call this distance x. So from here to here, let's call this distance x. So if they ask you, how far does the ball go? Well, now that you know the time, you can say, well, Mr. Parvaiz, I know how long the ball is traveling in the air, and I know its x velocity, which is v naught x, and I know the fact that the x velocity is not changing. If the x velocity is not changing, then I know that the x velocity, the v naught x, is my average velocity. So in essence, you not only have the time from the previous step, but you also have the average velocity in the x direction, which is the same as v naught x. The average velocity in the x direction is the same thing as the v naught x, because the v naught x is not changing. If it's not changing, then it's the same thing as the average velocity. So if you have the average velocity and the time, you can find the distance using the simple concept that average velocity is distance over time. If average velocity is distance over time, you can put down your v naught x for your average velocity, and you can put in your time that you've already determined for the entire trip. You multiply the time with the average velocity in the x direction, and voila, you will find your displacement in the x direction. Hope this was useful, and I'll review some similar concepts in class also.